All right, time to get started. Welcome back. We're now on day 3, programming in Kotlin, working on a personal finance app. Server is going to be written in Micronaut. And today we're going to start to look more at database migrations, which we got set up in the previous stream. Then we're going to start to take a look at setting up our first test, and we might even get to the point where we set up a full-blown kind of test harness, test environment with Docker and Docker Compose. So let's go back here and take a look at what we did in the previous stream real quick. So in the previous stream, we set up a tool called Flyway, which is a database migration tool, and it's essentially kind of version control for your database schema, and it can be run at the command line. It can be run as part of startup. It can do quite a bit of things, and it's fairly well integrated, nicely integrated into Flyway or into Micronaut. And so we set this up, and we basically give it a folder where it looks at for the database migrations, which are essentially just SQL scripts that can create tables, do any sort of database commands that you might want. And we created just a simple V1 to create a accounts table. And if we open up our database organizer here and connect to our database, let's just make sure that database is still up and running. Yep, still up and running. You can see our accounts table is here. And we also have this schema history table. And this schema history table is essentially Flyway keeping track of all of the different schema migrations. So you'll see the exact name that we have here, the description, create account table, version 1, and all this information about when it was run. So if we do another migration, Flyway will start up, take a look at this table, take a look at the files that it has in the specified migration folder, and it will then run those sequentially and run those scripts against the database. So we can go ahead and create another one of these just to show you that it's working. It's not just a one-off thing, and that it'll do another migration. And then what we're going to do is we're going to actually kind of start to try and write a test. And we'll talk a little bit about testing and kind of my thoughts or how I like to test, and see where we get and try and make a testing environment so that we can easily run all of our tests within Docker and Docker Compose. So let's go ahead and create another migration. We'll call this V2, and we'll call this, what do we want to do? Let's, what do we want to do? Before we do that, let's take a look at, we put together a bit of this schema here. So let's put together our transaction table just for fun. V1 create transaction table. So we're going to create our table transactions. It's going to have an ID, title, description, and then a value. And we're also going to want created at. And this needs to be a value that is acceptable for fiat or money. So you have to be careful here with what database type you use. It's definitely not going to be null. And in Java or in Kotlin, when you want to represent money, you typically want to use big decimal. Oops. Yeah, this is what you want to use. So basically, this is arbitrary precision signed decimal numbers. And actually, if you look at, I think Apache Commons money, yes. So basically, there's a currency and money API, and like many Apache APIs, right? They have a better thing on top of it. There's also a JSR for this, and so this is one way to go. But essentially, if you're representing money, you need to use a more precise API than just double or float, right? Those don't cut it. So you need to use big decimal. And this has all sorts of basically operations, adding, subtracting, things like that. So you can't just add two big decimals, right? When you add things, you have to use those values. You have to specify a rounding mode, which in if I'm not mistaken, is you want to use round up is usually, I believe. Yeah, typically you use half up rounding. This is what I believe I've used in the past. It does depend on what you are, or what scenario or what situation you're in. But typically, if you want to add money, particularly where I am in the US, you would set the scale, right? So you always want to set the scale to be 2, meaning you care about 2 decimal places worth of precision, and then your rounding mode is half up. So let's see if there's anything else. I know that I can't remember. There used to be a great article about this. So I'll have to see if I can find it, and if I find it, I'll put it in the chat. But let's take a look and just verify and validate how to store big decimal. And I assume it's just numeric or decimal. Hopefully big decimal is value guaranteed. Money data on PostgreSQL. Numeric decimal. Arbitrary precision. You should specify the scale to avoid the default scale of 0. Which, same as big decimal. Postgres actually offers a money type, but probably not the best. Scale is set by a database-wide configuration setting based on the locale. Yeah, that's not going to work. Yeah, that's interesting. Yeah, okay, so we want to use numeric. And numeric. User precision. Precision and scale. Precision must be positive, the scale 0 positive. So the number 235141 has a precision of 6. 1, 2, 3, 4, 5, 6, and a scale of 4. 1, 2, 3, 4. Yep. Selects a scale of 0. So this is interesting. I would assume, so in some cases, like if you're purchasing stock and you have a fractional share, this may or may not work. But for now, let's just go with we just want to set the scale though, not the precision. Numeric types with examples. Scale of 0, not what we want. It's interesting that you have to set that. I'm kind of surprised that you have to set precision but not scale. I'm sure this will come back to bite us in the later on. Big decimal and money confusion. Postgres.org. Yep, you don't want to use floats. That's bad. No, I don't think we want to use the money types. Yeah, here we go. Big decimal. Yeah, so this is a good, yeah, so here's the thing, right, is that, yeah, you have to use big decimal, yada, 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 currency, you're gonna have rounding issues. Yeah, set scale to round half up. And we'll look at we'll look at this in Kotlin. We can actually make some extension functions to make sure that this always happens. Use big decimal for money values. No. And I guess it can just be arbitrarily large. Let's just do 102. I guess it doesn't really matter for now. We'll give this a whirl and see what happens. We can come back to this. So creating a table. So again, if we go ahead and just run this, it's going to do a baseline, and then it will migrate that next table. So let's go ahead and run the project again, see what happens. And nothing. Oh, V1. Yeah, okay. So if you have a migration, you have to have your migrations named uniquely. So I just copied and pasted this file. So we're going to rename this to V2 and run it again. So basically there was a clash, right? You can't have a migration with the same number. Version 1. So this version 2. So this is started up. Successfully applied 1 migration. And it said basically, current version is 1. We want to go to 2, create transaction table. And now if we open up our database again and refresh, we should see transactions, which is what we've got. All right. So again, concept of migrations using Flyway. You can have any number of files with versions and names that specify your SQL scripts to apply migrations and kind of keep your database in check and up to date. So now that we've got this running and working, let's move on and let's talk a little bit about testing. So I like to start this and do this early on in the project so that it's set up. There's kind of less dependencies. There's not as many hassles in getting this infrastructure all up and running. And I'd like to also set up a separate Docker environment so that this works properly. And then it makes it easier to kind of rule out any machine issues or anything like that. So essentially what we're trying to do is we'll move all of this into a Docker container, run it in Docker Compose. It'll have a database. It can start with a fresh database every time, and then the test suite can run kind of in isolation, which is kind of nice. So let's talk a little bit more about testing. So for a long time, and many of you will be familiar with this, but this test pyramid. And so a long time, right, the thought is that you want more tests at the bottom of the pyramid because they're easier. And as it goes up, you'll have less tests because they're harder to write, or they're flaky, or they take a long time to run, whatever it is. Now, and I think as things have changed and with Docker and whatnot, there's this concept of the testing trophy, which I think is pretty interesting. And it boils down to, or it changes things a little bit. It basically says you want to rely heavily on as much static checking as you can. So this is things like linters, the compiler, and so you want to rely heavily on things that can be done statically or at kind of build and compile time. And then you want a good number of unit tests, but the bulk of your tests are really integration tests, right? And that's really kind of testing more things end to end. And then at the top right, you have kind of your end-to-end or functional tests, right? So this integration thing, right? And I think Guillermo Rauch and others have said, right, like write a lot of tests, mostly integration, that sort of thing. So this is what we're going to do. This is what we're going to set up, and this is why we're going to use Docker, because we're going to want our tests to really kind of run end to end, right? So from request to database and back is kind of what we're going to set up our system for. So let's go ahead and take a look at what Micronaut can do for us. this is an area where I think Micronaut is probably going to be pretty good for us, because one of the big benefits of Micronaut is kind of, you know, small, fast startup time. And so hopefully they have some nice testing capabilities. Vertex and Spring both have a lot of these where you can kind of literally spin up an entire container here. And so we'll give this a shot. Oh, and my dog is whining. Can I help you? Can you come hang out? All right. Okay, so I'm going to test with JUnit 5. And just because that's what I'm most familiar with. And so let's go ahead and take a look at how we set this up. It's probably pretty similar to other testing frameworks. I'm sure that there's some dependencies, so let's take a look. So test annotation processor, so Micronaut inject Java. It looks like we already have that from our starter. JUnit 5. Micronaut test JUnit 5, which we've already got. The Jupyter, oh, this is Mockito though. Does this have Mockito? I don't know if we're going to do any mocking now, if we're fine, but we do need the Jupyter Engine 5, which we've already got. Yeah, JUnit Jupyter Engine. And then we also already use the JUnit platform. So most of this was already set up when we set up the project. What did my dog eat? You done eating stuff? All right. Okay, so writing a Micronaut test to JUnit 5. So this is just Micronaut test with the service, parameterized test, environments class path. Using Mockito mocks. Specify the application class. Don't need to do that. Collaborators. Requires. Test specific properties. So what I really want to do is I just want to set up a simple, like, kind of checked that the world is running, right? So all I want to do right now to quickly get the test stuff up and running is basically just write a test that runs against this endpoint with something like rest assured or something like that. So that's what we're looking for here. Dun, dun, dun. So let's take a look at how you do that. Find the source code of this repository. Okay, so Micronaut. So let's just take a look at Micronaut guides. Testing the application. Yeah, so this is essentially what we want to do. Create a controller. Yep, we've got a controller. Create a Spock test. Micronaut test. Okay, so maybe all you need to do is just add that Micronaut test. Well, let's give that a shot. Kotlin. So we're going to do hello controller tests. It's not going to extend anything, but it is going to be a Micronaut test. And controller says hello. So the first thing you always do is just make sure your tests are running. And instantiating tests. All right, so our test failed, as it should, because when we assert true, we're telling false, so that's good. So that's working. Now, yeah, so Micronaut test starts the embedded server and injects the beans. These annotations use the internal Micronaut features and do not mock any part of Micronaut itself. When you run a test within Micronaut test, it's running a real application. Cool. All right. So is there an example? Yeah, there is. HTTP client. Okay. So let's do a HTTP client. Micronaut HTTP client. Inject. Bum, bum, bum. Yeah, it's not gonna like this. We want late init. So this is a Kotlin thing. We'll cover this a little more later on. But essentially what this is doing, why aren't my keyboard shortcuts working? There we go, everything. Okay. So when you use it in Kotlin, val and var, right, specify whether or not things can change. And when you use injection, you have to tell Kotlin that this is going to be late init, and that it's going to change so that you don't have to define this as nullable. So, so basically client dot retrieve, and this is just on slash, let's make this slash hello. And I assume this gives back let's take a look at the Micronaut HTTP clients, and I wonder so the HTTP client looks like it's RX based out of the box. Higher level AOP driven API. Use a low level. Oops. Where is, do they talk about the AOP? Declarative HTTP clients with client. Yeah, interesting. Oh, okay. That works essentially just the way retrofit and JDBI work. Okay. Let's client.toBlocking.retrieve. This returns a string. So we're going to assert equals and we return this. So that's what we're gonna assert. And let's go ahead and run and see what we get. And I'm not going to go too much into this RX2 blocking thing, but it's basically by default it's a non-blocking HTTP implementation, so you have to call to blocking on it when you're running kind of in this test context. No, it says request URI specifies no host to connect to. Okay, I'm guessing we have to do something different in a test. Client is /Micronaut test. No host exception. Did it start up the server? Can't do Windows. Yeah, we know that. Active environments, failed to load driver. Yeah, that may be a problem. So it's trying to connect to our test device. Okay. So yeah, so it looks like it's just not starting up because it doesn't have the Postgres driver in test. Did we limit Postgres? second. Am I crazy? Did we? Oh, we're looking at the wrong. No, we're looking at the right one. Where did Postgres go? We added that dependency. Did we not? Am I losing it? Didn't we add that dependency? Yo, man. Okay, maybe I did something stupid there, and that's, yeah, it looks like I may have done that stupidly. Still complaining. Nope, start it up. URI specifies no host to connect to. Okay, so it's not that. So well, let's start up our server and just make sure that that's still doing the trick, you know? Discovery client, what? Page not found. Hello from centerboard. Run this again. Up and running. Should be nothing there. Okay. So that's working. And let's run our tests. I see something in here. Creating bean for class 1 type element, incremental annotation processing requested but supports disabled because. Ooh, do we have to add something to. Do we have to add something like we did before? Because remember we added something in here. Run Gradle task. Dun, dun, dun. Test classes, maybe? Is that the problem? I have a feeling there's just something wrong with the client. We're just doing something wrong on the HTTP client. You are no host to connect to. Okay. So let's just make this really easy and dumb. Remove any changes or ambiguity. And maybe our client just isn't working. Yeah, okay. So it's just the client. So it's just the client's not working. All right. So this is fine. Okay. So in some tests, you may need a reference to the application context and or the embedded server. For example, to create an instance of an HTTP client. Oh, okay. So I'll bet there's something to this test. Inject the bean in the application context, which we are doing. Only to be used in conjunction with link. URI specifies no host. Is this the client or? Let me guess. Yeah, that's a URI. Okay. Okay. It wants a URI. Let's go back to the HTTP client and learn more about this. So client.toBlocking retrieve URI. Yeah, this should work. I shouldn't have to do this. Oh, that does put get in front of this like this. Okay. Oh. Not that I think that's going to fix it, but. Micronaut, embedded server is considered a shared test field. And this has got to be using late init, right? Yeah, late init. So maybe embedded server inject at field : client blocking retrieve. Yeah. Okay. URI specifies no host to connect to. Micronaut test at inject at field client. Starting to think there's something going wrong, something I'm missing here. Oh, there we go. Okay, that was it. Okay, so I don't know if I actually even needed this server. I suspect not. But maybe it is. Shared test field, I'll have to look into that. I don't think you should. Yeah, you shouldn't need that. Yeah. So the big thing that I was missing here is this at field. And this is annoying. This field thing is a backing field. No. Annotations field. Yeah, so basically you have to do this because this is you're injecting specifically a Java field. So that's why this client wasn't working. So if I take this off here, in Kotlin with annotations, sometimes it's a little finicky if the thing that is backing you is in Java. And so to kind of bridge that gap, they have this at field annotation. So, okay, so we've got a working test that runs, spins up the server, actually goes end to end. This is a pretty good, I guess, basic working integration test. Now, the last thing we're gonna do, it's 9:52. Last thing we're gonna do is we will try and get a Docker Compose set up here that will take all of this, compile it, and run the test all at once in Docker. So essentially what we do is we take this, but rather than the jar, we take the source code, bundle it all up with Gradle, and then run the tests. So we're going to copy this. We're going to call it .test. And we're going to associate this with Docker file so that we get the nice syntax highlighting. Okay, we don't need to expose anything. We don't need to copy. Essentially all we're copying is source folder. And this is copying over to source. Well, probably should be a good citizen here. So on the Gradle side of things, and this is where I'm going to steal some stuff from a previous project. So dockerfile.test. Yeah, so from Gradle root folder, yeah, okay. So we're going to use the Gradle Docker file because it comes with Gradle. And we're going to use 6.5. Actually, let's see what we use so we match it up. 6.3, so we can bump this to 6. Dot 5, and then we can bump this to 6.5.0-JDK14. And then we got to do a couple things. So we're going to set up an environment variable, which is going to be basically our root folder. So this is going to be here. And then basically as root, because Gradle the Gradle Docker file is pretty strict, we are going to create the root folder, and then we're going to give permissions to the Gradle user to root folder. And then as the Gradle user, we're going to take ownership of what we're copying over. And what do we want when we want to copy over? We'll just do everything. And I'll show you also another kind of trick of the trade is just like Git has the git ignore, there is also a Docker ignore. So we're going to go ahead and do a Docker ignore. And what are some things that you ignore in here? So you ignore kind of your typical stuff. So any of your project files, you don't want any build or class files or anything like that. So basically this just keeps all of your stuff that you don't want, out of your Docker container. So we're not going to want Docker file. We're not going to want docker-compose.dev. We don't want the git ignore, right? Git ignore, those sorts of things. So basically what will happen is when we copy this root directory, like we've asked here to do, it's not going to copy over all of this stuff. And then we are not gonna do, well, we can do a command here. Are we gonna do it with a test? I typically don't put a command in here other than setting the workdir. Because I typically will run the command in Docker Compose, but in this case we can run Gradle test. So recap, right? So we're using the Gradle Docker image. We are defining an environment variable, right, which is just where we want our stuff to live, and we're going to do it there. We're going into the Docker container as a root user. We're creating the folder for where we're going to put everything, and we're then basically changing the permissions of that folder to be owned by the Gradle user, which is a non-root user. We're then switching to that Gradle user, copying over the files and taking ownership at the same time. And we're basically copying the root project directory into that root folder and then setting the directory where we're starting from in there. And then we're going to run Gradle test, which should do what we want. And so, for example, it's essentially like doing the same thing here. I want another Ubuntu shell. Source So it's the same thing as if we were to run Gradle W test here. Oh, because I'm in Ubuntu, right? Yeah. So it's essentially the same thing as if we were to run. We'll set that up later. Where is... Why wouldn't that be... Oh, this isn't Unix, right? Yeah, okay. Yeah, so let's just give this a run. Let's see what happens. Run built image, none of this stuff. Docker auto detected server, context folder. Let me check. Unable to auto detect settings, manual configuration required. Oh, this is the joy of Windows. Actually, we should be able to run this. Yeah, let's just go ahead and do the Docker compose thing here real quick. So we're gonna undo this and set this further up for the next stream. And essentially what we're gonna do is create a Docker Compose test file that runs and just starts up our system here. So let's take a look at our cheat sheet here. So basically we can tell Docker Compose, rather than using like a pre-built image, we can tell it, so use the current context, so dot, so current directory, and then you can give it a Docker file, and we're going to give it dockerfile.test. We don't need to give it a command or anything like that, because the command runs in that. Actually, if we're going to do this now, we should probably take that out. And let's just go ahead and change that. So sh-c, and then we're going to run Gradle. And then when you're running in CI, there's no point in starting up a daemon. Test, we're going to want to fail fast. Console, we want to be plain, and we want to stack trace. Okay. Yep, and then in our dockerfile.test, we can just remove this because we're going to be running it anyways. So now what we can do is we can basically spin this up by running the following. And we'll create, actually we'll create the make file. So I typically create a make file for this that basically has a test command in it, and we run docker compose -f docker. So we pass it the file, we say up, we build, we abort on container exit, we take the exit code from Centerboard API, which is what we named here, the service. So that it'll take the exit code from this to tell us if our tests pass or not. And we can force recreate. Okay. Dun, dun, dun. So let's okay. Let's install make. So I'm really just creating this make file as a shortcut for this command. You know, you could do it in a shell script or whatever, but I just do this because normally make is literally everywhere. And so what this is doing, and this will be helpful and useful in the next stream when we go into actually writing tests that hit the database, is this will actually spin up the entire environment. So it'll spin up our database, it'll spin up our API, or spin up our testing setup, right? Where it actually spins up a test environment or a test or an embedded server. And then once we add actually endpoints that hit the database, right, it'll run this all in its own entirety. So we're going to run make test. So it's going to build our API from Gradle. It's going to pull down all of the layers. Hooray for fast internet. Creating all of our stuff, spinning up our database, running Gradle, and it failed. Okay, so what did it fail on? Failed to create parent directory. Okay, so this is just a permissions thing. Gradle could not start your build. Failed to create parent directory. Home Gradle Centerboard API .gradle. Could not create service of type cross build file hash cache. What? Oh, failed to create parent directory, yeah. Okay, so it doesn't have the right permissions, which is a little odd because we gave it permissions. Okay. Folder. Why can't it create a directory in the directory that it's in, that user owns? Let's I mean, see if the root user has any trouble. Okie dokie. Test not found. Okay, so the root user doesn't have an issue, so that's definitely a permissions issue. So we can fix that. But why? Why is there no is it search? There we go. Open JDK JRE. Open JDK 14-JDK. Open JDK-14-JDK. Super redundant. I was actually confused as to why test isn't showing up over here, so that is quite interesting. Maybe, I mean, we're using JUnit 5. We told it to use the test library, so that's a little curious. What is this running? Test. Huh. Okay. Gradle task. Test runs all the tests. Okay. So why don't you run the test? This runs the tests. Okay. Maybe that's the problem. Maybe, just maybe, that's the problem. That's interesting. I don't think I've ever seen that. Could not copy file. Can't copy file to the build folder? What? Okay. Anyways, let's run. Nope. Let's run this again. Something's weird here. Test error 127. Gradle W not found. Okay. It should definitely be found. It's right there. Something's missing. Something is missing here. Let's run this and inspect what is in. Oh yeah, that's right, I can't do it here. All right, so now Dockerfile debugging. This is fun. That's still running, right? There's nothing in the folder. Yowza. There's got to be something in the folder. Is this like a dumb WSL thing that this doesn't work? Because this definitely works here. Like, this has to work. There's no way this doesn't work. in the Centerboard API folder. It's running LSA and there's nothing in it. Did I do something stupid in my Docker ignore? Seriously, IML build Gradle idea. Yeah, should be fine. Okay. There's nothing in the folder. What? Are you kidding me? How can there be nothing in the folder? Well, at least this is still working, right? There ain't nothing in there. Copy everything in the current directory. Really? Let's play around with this here a little bit, because this doesn't make any sense. It's not copying anything. Oh, or it's because root can't see it. Nope. It's because there's nothing in there. This definitely works in this project. Yeah, I'm gonna bet this is something with here. Okay. Docker compose an incorrect absolute past. Yeah, I'm gonna bet that this has to do with WSL. So what we gonna do is yeah, it's not gonna find this. Okay. Well, that's slightly annoying. We're gonna have to figure that out. Oh, that's really dumb. So I'm pretty sure that this just simply isn't working because it's in WSL. So maybe, just maybe, we can run it on the Windows side? Oh, but we don't have make. Okay, I think we're just gonna have to stop for now. But the idea is that we should be able to run this thing with no issues. And basically it starts up, runs the test in its own isolated container, and then spins down. But I'm gonna have to look into why WSL doesn't work, or why it doesn't copy this stuff over, which is annoying. So I think that's it for tonight. So did some more database migration stuff. We then wrote a test. Where did our controller test go? That actually spins up the embedded server and hits the actual endpoint. We can get that back up and running if we, oh, it's over here, right? Yeah. If we bring up our dev server, we run this test rate, it literally spins up and runs the embedded server, connects to the database, does its migrations, even though it's not actually even hitting the database yet, and then runs a hello world controller test, which is cool. So I need to look into how to fix this and how to get this working. But hopefully in the next stream we can get this fixed and we can start running actual tests in kind of its own little world in Docker end to end, because then we can run kind of the entire test suite at the command line or locally if we want to, all in its own little world. But we have to figure out why when you run this, it does not copy over the files. It's empty, which is a major friggin' bummer. So we'll take a look at that. I will hopefully figure that out in the next stream. I'll take a look at this offline and see what I can find, but that's about it.